If you can see my screen, type yes. If at all you can see my screen, type yes. Type yes. If you can see my screen, type yes. So we are beginning with my heading is forces acting on polygons. So we have different polygons. We have a square, we have a rectangle, and we shall also be looking at a hexagon. So basically, the most examinable polygons are those three that I have talked to you about. We have got a square, a rectangle, and a hexagon. Now, we need to note the following as we progress. You need to note that if we say that a polygon is regular, yeah, we have to note, before we go any further, we have to note that if the polygon is regular, if the polygon is regular, then it means that, number one, its sides are equal in length. Its sides are equal in length. Number two, all the interior angles are equal. All interior angles are equal, and the exterior angles are also equal, and exterior angles are also equal. We need to also note that interior angle is given by getting 360, we divide by the number of sides of the particular polygon. Another thing that we need to note, this is A, if the polygon is regular. B, we need to also note that the direction of forces, the directions of these forces, must correspond to the order of lettering. For example, if a force acts in directions AB, or in the direction AB, the arrow, you must note that the arrow of the force must point from A towards B. So if what I'm trying to mean, if maybe a force, if I have point AB and they say AB, you have to follow that order of lettering, meaning the force must be pointing from A to B. So I'll be having a certain force, Newton. That is what I'm trying to mean. So these are among the few things that we should know so that we progress well. So that is a brief introduction about what we are going to look at. So basically, we are going to immediately go to examples. We're going to go to examples. Oh, yeah. Rogers, thank you for that correction. Thank you for the correction. Thank you for the correction, please. Onenchan has corrected me here. This is the formula for the exterior angle, not interior angle, but instead exterior. This is for exterior angle. For the interior angle, that is when we have n minus 2 times 180. For the interior, it is the same as 180 times n minus 2. This one will always give us the interior angle. But for exterior angle, it is 360 over the number of sides. Yeah, so without wasting any minute, let's move to examples and we see how we resolve forces on a polygon. Number one, forces of 4 Newton, 3 Newton, 6 Newton, 5 Newton, act along the sides of the square. Act along the sides of the square ABCD. In the directions AB, BC, CD, DA, respectively, find the resultant force. Solution. They have told us a square. Draw that square. A, B, C, D. They have told us AB, so we have AB, BC, BC, CD, CD, DA, DA. Put forces. They have given us 4 Newton along AB. They have given us 3 Newton along BC. They have given us 6 Newton along CD, and then 5 Newton along DA. So here we resolve forces after. That is all we need. So we have to resolve forces. Resolve forces. Or resolving forces. We begin with the horizontal forces. Horizontally. And when we say horizontally for this case, we mean parallel to AB. Forces parallel to AB. So if you resolve forces parallel to AB, it means that if this is AB, you are resolving forces parallel to AB. So it will be, of course, on straight lines on the x-axis, the angles are always 0. So you'll be having 4 cos 0. This one cannot be a parallel, cannot be a horizontal force. Neither can this one be a horizontal force. So what we shall say, we shall be writing 4 minus 6. Why do we say minus? Because at this point, we are going to the negative, to the negative direction. So those forces constitute to x. That's why we say summation of x is going to be equal to 4 cos 0, which is 4 This one being a vertical force and this one, they cannot have horizontal components. So the horizontal components, we are just looking at this and this. We are looking at this and this. So what we do, you write 4 and this one of 6. So it will be 4 minus 6. Don't look at these vertical forces. Maybe if at all you had some force inside, but these forces which are on straight lines like this, but horizontally, they can't have, rather vertically, they can't have horizontal forces. So it is the same as 4 cos 0, but I wouldn't write the cos 0 because cos 0 is 1. So it is 4 cos 0, which is 4, minus, because I'm going to the negative, minus 6 cos 0, which is 6. So this one gives me negative 2. Then if we resolve vertically, vertically that is parallel to AD. Yeah, one can say parallel to AD. Even if you don't put the word parallel to AD, you are just resolving vertically. Vertically, we have summation of y. And the first one is this. At this point, we have 90, 90. Yeah, right angles. So this will be 3 sine 90, which is 3, because sine 90 is 1, minus 5, because it is the negative. So 5 sine 90, which is minus 5. I'm not considering 4 and 6, because since they are horizontal forces, they can't have vertical components. So this is also negative 2. Then there I get my magnitude R, which is equal to the square root of negative 2 squared plus negative 2 squared. And this is the same as root 8, which is the same as 2 root 2 Newton. If you're with me about how I've gotten my resultant, type yes. We have just started. We are going to do very many examples. So if you're with me there, first type yes, and I take you ahead. Okay, so I think after getting this, every person can get the direction. Yeah, every person can get the direction. And if we have to get the direction together, you need to note the directions of these horizontal forces and vertical forces. So for direction, I'm having negative x, because negative x, this is negative 2. So negative x is in this side. But when you have pointed it this side, you just put a 2. And then after that, we have negative 2 in the y. So we have negative 2. You just put 2. Then, of course, you complete it. So this is x and this is y. So if this is 90, I'm looking for this angle theta here. So I'm going to use tan, and tan theta is equals to opposite of adjacent. So theta is the tan inverse of 1, which is 45. And therefore you conclude and say the magnitude of the resultant, is 2 root 2 Newton, acting in the direction, 45 degrees downwards, or with, one can say, with BA produced downwards, with BA produced downwards. This is BA, but it is produced downwards. So one can conclude like that. Or with the acting at 45 with the negative x-axis, or in the negative x-axis. So still that one will carry sense when you conclude. If you're with me, please type yes, because I want us to do, like, for examples on each polygon. I want to give you an example on each polygon, then I give you some work to do. I want to give you some work to do. Okay, so without wasting time, I'm rubbing off this, or you can take screenshots if you're using a phone, so that we go to another example. Number 2. Forces of 4 Newton, 3 Newton, 5 Newton, 6 Newton, 5 Newton, 7 Newton, act in the directions AB, BC, CD, AD, SC, DB, respectively, of a rectangle ABCD. Where AB is 4 centimeter and BC is 3 centimeter. Find a resultant force. This is the most interesting question. Solution. Now, here, I want to first show you the common mistake that learners make. If you're given this rectangle, the rectangle has got, unlike a square, it has got few lines of symmetry. Those are 2. Okay, depending, it has gotten some lines of symmetry, but not like a square. So if you look at, when one draws a rectangle like this, and we say A, B, C, D, and maybe there is a force inside. If there is a force inside, it means that that force is acting at some angle theta. This angle theta, my friends, is not 45, but for a square, it is 45. What makes the one of the square 45? Because the square has got equal lines of symmetry. But for this one, you have to find it. That's why they have given you distances. So you can use these distances to find the angle that is within. Okay, so without wasting time, we shall use the dimensions given to get, the angle. So if this is ABCD, they have given me AB as 4 and BC as 3 centimeters. So if this is 90, I can get angle theta. So the first thing to do would be, it's a matter of just using the dimensions. We need to first get, you can get this side also. So this side, we shall have, you can use Pythagoras. It means that AC squared is equal to 4 squared plus 3 squared. So AC is the square root of 25, because this is 16 plus 9. So AC is equal to 5 centimeters. So if this is 5 centimeters here, it would mean that it will begin with, the solution actually starts from this side. Solution has started from there. So you can use, you can get sine theta. You may not necessarily get the value of theta, but sine theta and cos theta, so that we maintain them. So sine theta, because we resolve in terms of sine theta and cos theta. So sine theta is going to be opposite over hypotenuse. So it is going to be 3 out of 5. And cos theta is going to be 4, because cos is adjacent over hypotenuse. So 4 over 5. Then now you come and you put in the forces in your rectangle. You have forces, and these forces are A, B, C, and D. So AB, they give us AB, and AB is 4 newtons. They gave us BC. BC is 3 newtons. They give us CD. CD is 5 newtons. They give us CD. Then AD. AD, you have to note that very well, not DA. So AD means is facing up. AD, and that is 6 newton. Then they give us AC, A going to C, and that is AC, meaning here is at angle theta. So AC, AC is 5 newton, and then they give us DB. DB, you're coming like this. So DB is here, and that DB is 7 newton. So also at a certain angle theta. So it's that resolution of forces, resolving forces. Horizontally, we shall have the summation of X as the first horizontal force would be 4 cos 0, which is 4. We move, this one doesn't have, because it is vertical. This one will be minus 5. Minus 5. This one, the 6 doesn't have. And therefore, we shall just now move to this. This one is in a positive side. It's going in positive direction. So it is going to be plus 5 cos theta, because the angle is here. 5. The moment it is not on a straight line, then it has to be acting on a certain angle. So 5 cos theta, and I said plus because it's pointing in the positive direction, but this one is pointing in the negative direction. So it will be minus A. Is it? No. Its horizontal force is also going to the positive east, because this side is east direction. So it is plus 7 cos theta. But I have values of cos theta, cos theta. So it will be 4 minus 5 plus 5 cos theta. Cos theta is 4 out of 5. So 5 into 4 out of 5 plus 7 cos theta, which is 4 out of 5. So working on this, ladies and gentlemen of Christ, this is going to give you 80.6 Newton. You will ask me after I have done maybe the vertical, So vertically, when you resolve vertically, we shall have the summation of y forces. The first y, this 4 cannot be a y force, but 3, it is 3 sine 90, which is 3. This 5 cannot be a vertical force. This one here, 6, it is in the positive direction, up, positive north, so it is up. So we shall say plus 6, because it would be 6 sine 90, so just 6. Then plus, you ask yourself, where does this force of 5 act? This force of 5 is going in the positive direction, so it will be 5 sine theta. But this one of 7, it is going in the positive east, but negative y. So it will be minus 7 sine theta. So this is going to be 3 plus 6 plus 5. Remember, a sine theta is 3 out of 5 minus 7 sine theta, which is 3 out of 5. Working on this, this is 9, this is 3, and this is 21 out of 5. You're going to have, is it 7.7? 7.8 Newton. If you're with me, type yes. If you're with me, type yes. If you're with me, type yes, guys. Wow. This is good. So it's all about the direction of forces, the arrow, and you knowing if the arrow is pointing down, is the horizontal positive or negative? For example, here I've said that for vertical force, 3, we don't put a 4 because 4 is just horizontal. Even if you say 4 cos 4 sine 0, that is 0. So we start with this 3, which is a sine, 3 sine 90, which gives it 3. Then you come to a 5. 5 doesn't have a vertical force. Then you come to 6. 6 is pointing up. Therefore, it would be plus 6 sine 90, which is the same as 6 times 1, which is 6. Plus, when you come to this 5 now, 5 is pointing in the positive y. It is pointing in the positive direction, up. So it is 5 sine theta, but sine theta, we already have it here. But when you go to 7, this 7 Newton force, it is pointing in the negative direction, meaning in the south, it is going to the south, which is negative, negative y. That's why I said minus 7 sine theta. Simple as that. So after getting these two, I do believe you can get the resultant, and the resultant is none other than taking the square root of the squares of these forces when they are summed up. So it is the same as 8.6 squared, and you add 7.8 squared, and this one will give you the resultant as 11.6 Newton. After getting this, if it gives decimal places, preferably put it for decimal places. That is it. Let me see. The calculator I'm having is just dash, just a dash. So after getting this resultant, you can go ahead to get direction. They are both in positive direction. X and Y components are in the positive direction. So positive X, positive Y. That is how I would expect your sketch to be for the purposes of the direction. So this is 8.6 and this is 7.8. If I complete the square, if you complete the square, rather direct the triangle, it will be like that. And here is where you have your resultant, which is 11.6 Newton. But remember, this is y-axis. and this is x-axis. So by using tan, you can get your answer. By using tan, one can say tan theta is equal to opposite, which is 7.8 over adjacent, which is 8.6. And this one will give you theta after taking the tan inverse. Maybe, let me call this one angle theta, at which the resultant acts. So the theta is going to be 42.2. Put to 2 decimal places. I'm just giving the actual says, but just appropriately record. So you will conclude and say the resultant of forces is 11.6 newtons acting in the direction of 42.2 degrees with AB upward Z. With AB upward Z. The resultant is 11.6 newtons acting in direction 42.2 degrees with AB upward. Something like that will give you the answer. Okay, if you're with me, guys, some yes. Okay, I don't want to waste any time because the issue of polygons has to end today. The issue of polygons has to end today, and we start another vibe. Shall start another vibe. Yeah. Because after this resolution of forces, that first one will be done. Then we go to other situations. I think I should go ahead. Bad thing, you guys don't hand in the exercises that I leave behind, which is not good. But if it works for you, it is okay. Number 3. Forces of 6 Newton. Forces of 6 Newton, 5 Newton, 7 Newton, 4 Newton, 3 root 2 Newton, 7 root 2 Newton, act in the directions, AB, CD, DA, AB, CB, AB, CB, then CD, then DA, CA, and DB respectively. On square, ABCD. Find the magnitude. And direction of an additional force When they say additional force, that is the resultant of an additional force that will keep the system of forces that will keep the system of forces in equilibrium. Solution. Draw a square. The moment they say on a square, just draw it. With a ruler, me, I don't have a ruler. That's why I'm drawing Vorongotos. A square has all sides equal. If mine are not equal, you as members make them equal. So if this is A, B, C, and D, you have said that forces of 6 newtons, meaning 6 newton, uh, 6 newton is on AB. Then they have said CB, CB. When they say CB, you move downward Z from C to B. That is 5 newton. CD, that is 7 newton. DA, that is 4 newton. CA, CA, that is 3 root 2 newton. Then DB, that is 7 root 2 newton. Now, with the square, since the line of symmetries are equal, everywhere is 45 degrees. 45 degrees. The moment you cut it into 2. So 45, 45. That is what we are trying to mean. So with the rectangle, you have to find the angles, cos theta and sin theta. But with the square, the moment you divide it, they are the same as 45, 45. If you're with me on how I've sketched, please type yes. Now, when we start resolution of these forces, it becomes very, 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 very easy. Resolving forces. We begin with the horizontal. Should I thank God for my network? Horizontally, summation of forces, horizontal forces. The first one is the first one is 6 newton because it will be 6 cos 0. So that is 6. Then another horizontal force is this one, which is pointing this side horizontally. So that is minus 7. Then now, when we go to these ones, where we have CA, you see it is going to the negative side of west direction. Yeah, so it will be minus 3 root 2 minus 3 root 2 cos theta, but our theta is 45. Then this is going to the positive side of x-axis. So it will be plus 7 root 2 cos of 45. This will be 6 minus 7 then minus 3 root 2 because 45 is 1 over root 2. If you don't know these sides, put on the calculator and get us the answers. Then plus 7 root 2, 1 over root 2. So this one will give us 6 minus 7 root 2 with root 2 will go minus 3 plus 7. And this will give us 3 Newton. That is the horizontal force. Then when you go to vertical, summation of y is going to be equal to vertical. The first force of vertical is in the negative direction, so it is negative 5 sine 90, which is negative 5. Another one is also this, which would be minus 4. I've not considered these two because they are horizontal. Then now I will take these ones now. Since this one is acting downwards, the 3 root 2 is acting downwards, meaning it's going to the south direction. So it will be minus 3 root 2 sine 45. Also, this 7 root 2 is going in the negative side of y. So it will be minus 7 root 2 sine 45. So this is minus 5, minus 4, minus 7, okay, minus 3, then minus 7, which is equal to minus 19, implying that my resultant is going to be equal to, you take the squares and the roots. So it's going to be coming. So we shall have the resultant as 3 squared plus negative 19 squared. Yeah, and this one is going to be equal to 19.2. But get your answer in 4 decimal places. I guess all of you can get the direction. All of you can get the direction. So how do you get the direction? The direction is gotten by you looking at the forces you're having. One is positive and another is negative. So everyone get me the direction. If you're with me, guys, type yes, because I'm going now to do the question of hexagon, and I will have called it a point for today. I don't want to waste time. Let me go to another question without wasting time, guys, because but time ain't there. Another number, which is 4. Question 4. Forces of 2 Newton (5 Newton), 3 Newton, 4 Newton, and 1 Newton act on a regular hexagon, act on a regular hexagon, A, B, C, D, E, F, A, B, C, D, E, F, in the directions Tumosime, you have the best direction, 81.03, that is good. In the directions A, B, C, D, D, E, E, F, and F, A respectively. We said that these directions must be shown very, 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 very properly. Yeah. So after this, find a resultant. Find a resultant first. Find a resultant first. This is very, 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 very magnificent. Very, 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 very nice question. But it needs you to be very, very, very serious. They have given us 2 Newton, 5 Newton, 3 Newton, 4 Newton. I think I forgot some force. It is 2 Newton, 5 Newton, 3 Newton, 4 Newton, then another 3 Newton, and 1 Newton. Yeah, then directions A, B, C, D, D, E, E, F, and F, A respectively. So if I first draw this hexagon, I'm going to show the inclined forces by using their components so that these forces can easily be seen. Yeah. Then the component of forces must originate from the initial point of each individual force. That is what we should know also. For the hexagon, there is no big love here. In hexagon, you don't put much love. You don't rush. Otherwise, if you rush, you'll be like, yeah, when it was brought and students failed it very, very, very well. So basically, what we do for the case of a hexagon, first draw it. I know you drew these things in primary level, so repeat it again. I'm trying to draw one here with my stubborn pen. So use a ruler and draw the best. So this is my point A. This is my point B. This is my point C. This is my point D. This is my point E. This is my point F. So I'm going to start putting the forces. Someone is saying it is cyclohexane. Whatever. So basically, AB 2 Newton. So you're going to put 2 Newton here. BC, they said AB I forgot a BC here. AB, BC. Correct anything. AB, BC. So BC is the one which is taking on a 5 Newton force. Then CD is taking on a 3 Newton force. Then DE is taking on a 4 Newton force. Then EF down is taking on a 3 Newton force. Then FA is taking on a 1 Newton force. According to what we have looked at, if I'm to give each one an angle, since we have been, you can find angles to insert, we can resolve each force, okay? Basically, when you look at a 2 Newton force, since it is acting on a straight line at 0, we don't resolve it. We shall keep it as 2. But this 5 Newton, since it is inclined, yeah, since this is inclined, these inclined forces, we are going to represent them by their components. So this is inclined force, this inclined force, this inclined force, this is inclined force. 5, this is 3, this is 3, and this one are inclined forces. And if they're inclined, we can represent them by their components. See, the exterior angles of a hexagon are 60 degrees. So this one is 60 here. We are having a 60. We get 360, we divide by the number of sides. So we have a 60 there, implying that the component of this force here is 5 cos 60. Yeah. Then 5 cos 30. Then the vertical force would be 5 sin 60. Then when you look at this one, the one of 3 Newton force, you resolve it vertically also and horizontally. When you resolve it horizontally, it is going to be 3 cos 60 degrees, having a 60 here. And the vertical component is going to be 3 sin 60. We don't have the components of this 4. We resolve the inclined forces. That's why we are going to resolve the one of 3. So when you look at this 3, here we are having 60 degrees, implying that this is 3 cos 60. Whereas here, we shall be having 3 sin 60. When you look at this one here, the 1 Newton force, we are going to have, here of course is 60. So we shall resolve this inclined force as 1 cos 60. And we shall resolve this one here as 1 sin 60 degrees. If you're with me on what I've drawn, type yes. If you're with me on what I've drawn, type yes. Okay, so after this, the rest of the issues are easy. Just you have to resolve only inclined forces, and with respect to 60 degrees. So it implies that if I'm to summarize what I'm going to be writing here, okay, the summary. If I'm to summarize what I'm going to be writing, I have those forces. I have those forces which are in positive x direction. I have the ones which are in negative y, and the ones which are in positive y, the ones which are in negative x also. So the forces which are in positive x, the ones where I will be using positive, the first one would be R2. I'm just summarizing, but we shall be looking at the diagram. The first one is R2. Another force will be 5 cos 60. It is positive and in the positive x. So 5 cos 60 degrees. This force here of 3 cos 60 is not in the positive. As you can see, we have taken it in the negative side, so it can't be positive 3 cos 60. So we shall not take this. It will be this side of the negative forces. So which other force is in the positive? 1 cos 60. 1 cos 60. Because this is in negative 4 is in the positive, rather negative, even this is in the negative. But when you look at how I've resolved the 1, it is 1 cos 60 and in the positive sense. So 1 cos 60. So these ones are in positive x. Then the ones which are in the negative x, the first one is 3 cos 60. 3 cos 60. Another one which is in the negative is negative 4, but I write 4 because I need the sum of them. Another one which is in the negative (3 cos 60). This 3 cos 60, then 4, and this 3 cos 60 also. So plus 3 cos 60. This summary enables you to know the forces that you are going to consider. Okay, so when you look at the y, the components of y, the ones which are in positive y, the first one is this 5 sin 30 is in positive y. So here we shall have 5 sin 60, 5 sin of 60, plus another one which is in the positive y is 3 sin 60, 3 sin 60 is also in positive y. But this one is in the negative. This one is in the negative. So we have only two forces which are in positive. Then the ones in the negative, we have 1 sin 60 and 3 sin 60. So 3 sin 60 and 1 sin 60. Now, after having gotten this summary, even if you don't show this summary, but you can work on it. So if I need the horizontal component, even if I show it like this one shows horizontal resolution, and that is the x. So it is going to be equal to, you sum up the ones of positive, then you subtract the ones of negative. The ones of positive are these, so we shall subtract the sum of these. So we shall have 2 plus 5 cos 60 plus 1 cos 60 minus, subtract the ones of negative, 3 cos 60 plus 4 plus 3 cos 60, which is the same as when you have, it's the same as when one has just subtracted each force independently, because this negative affects all these, meaning that all these forces are negative. When you work on this, it is going to give you negative 2. Then when you resolve vertically, the y components are going to be equal to the positive ones, 5 sine 60, 5 sine 60, plus 3 sine 60, then minus these ones of negative, the ones down, 3 sine 60 plus 1 sine 60. And this one will give you a force equal to 3.4641. After having gotten this, you can get the resultant, magnitude of the resultant, which is equal to negative 2 squared plus 3.4641. The moment you forget negative, you are wrong. So this is going to give you 3.99999, then 8, which is equally 4 Newton. For that case, you can round it to 4 because it's 3.999. So that is how, so you find the direction according to the way we have been seeing. Find direction. If you're with me, guys, type yes. If you're with me, type yes. If you're with me, guys, type yes. I love it. I love it, guys. You guys are very, 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 very super. Actually, you can make someone even feel like teaching you for free next time, because we are really enjoying. Me too, I'm enjoying. So this is super, 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 super. If you have not understood me, I will give you exercise. You try it out. After you trying the exercise out, you can be very fine. But these things, keep practicing them. Now, the questions which I will give you, you may find that a question, maybe part B of the question, need, for us, we have stopped on getting the resultant and the direction. But you may find that the questions that I'm going to give you will be needing the equation of the line of action, which we only get when we have covered the moment. So the questions I will give you, I want you to do only part A, getting the resultant only. Because there are those questions of UNEB where students were tasked to have been already tasked also get the equation of the line of action, but we cannot get that when we have not captured the moment. So I'm going to give you some numbers to do. I'm going to give you some numbers to do, and others I'm going to send them to your WhatsApp so that you can get a big deal. So in case one needs more examples, in case you haven't understood anything like here, please, you can inbox me and you describe your problem so that I work on it. Otherwise, we cannot go beyond here. But one of the questions that I want you to do, I'm going to write it. I'm going to write it here so that you do it. And then I see if you can get it right. So whoever that will do this question, forces of 8 Newton, 7 Newton, 6 Newton, 4 Newton, 7 Newton, 6 Newton, act along sides of a regular hexagon, A, B, C, D, E, F, in the directions A, B, CB, CD, DE, EF, and FA respectively. Find the additional force. We said that when they say find the additional force, that is the resultant. Find the additional force that will keep the system of forces, in equilibrium. Answer, you're supposed to get 12.49, but I would prefer 4 decimal places, and the direction, you're going to get 76 degrees. So that is the question I want you to try. But there are some other UNEB questions that you can't go without mentioning. There are those UNEB questions that are worth to be done. Ideally, there are those UNEB questions that I really want you guys to do. And one of these questions, oh Jesus, there are very many. So you guys, I want you to check those ones with the question bank. You can even check and post in the WhatsApp group for others to do the same questions. Those are Ugandan question bank. Some people have Kenyan question banks. So it was 2000 number 16. Of course, I'm talking about paper 2. Then you're going to also check 2010. Number 13, but I'm interested in you doing part A. 2009, number 12, you leave that part of the equation of the line of action, yeah? 2000, 2009, 2010. The even recent numbers, was it 2016? There are recent numbers. Let me check question bank here. 2016. Let me check, guys. Let me check. Let's see if we can get more numbers. 2016. I predict that here to have that question. Oh, it has ashamed me. Isn't there? Maybe I've been interjected it with 2017. I'm really perturbed where that number is. It can't be 2019. The more numbers you calculate, the more you understand. The more numbers you calculate, the more you understand. I can't easily see this question, but you can check 2017. It is about a square. 2017, section A, it is number, it was given as number 4. All those ones now you can do. I'm looking for a question of section B. Section B. Oh, yes. Oh, yes, it was. I was right. 2016. Number 10. You can do all that question apart from part B, which is 4 marks. So you can do part A, which is 8 marks. So whoever you feels like I should check on their question, after doing it, you send to my WhatsApp and I see. I wish you the best, guys. Let's pray that tomorrow, as we are having the physical chemistry, rather as we are having the organic and the pure, network behaves the same. We shall enjoy. I wish you the best, guys. See you tomorrow for organic and pure math, right? But those ones members, I will not repeat it, do the needful.